Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the internal working of vector DBs, how vector databases actually works. So first we'll have an overview of the working of vector databases. Let's have a look at the working overview. Vector DBs uses a combination of algorithms that optimizes the search process through methods such as hashing, quantization, and graph-based search. Now, inside vector DBs, a lot of different functionalities works. It uses combination of some algorithms. Now, why it requires to use all these algorithms? Because in the previous video, I already have told that in vector DBs, whenever we have to perform a search operation, we not only have to just search for the match of the query, rather we have to find out the closest match for that particular query. Now, to perform the operation of finding out the closest match, a lot of computation power is required. And because of which, the time that is required to perform such operation will definitely increase. And just to balance that particular time for retrieving certain amount of content from the vector database, we'll have to use all these strategies. And that is why vector DBs uses this combination of algorithms. It optimizes the search process through the method of hashing, quantization, and graph-based search. Now, whatever combination of algorithm we are using in this particular vector DBs, we cannot use it randomly at a time. We'll have to set the flow. And that is why these algorithms are assembled into a pipeline designed to quickly and accurately retrieve the vectors that are similar to a particular query vector. So, all these algorithms that we are going to use will assemble those into a particular flow, into a particular pipeline. This pipeline will help to quickly retrieve the relevant data that is similar to a query vector. Unlike traditional databases that look for exact matches, vector DBs use similarity matrix to find out the closest matches, allowing for approximate results. So as I already have told you, the traditional databases looks for exact matches, that the query has to be exactly matched with the data present in that particular database. But here it's not like that. Here we have to find out the closest match for that particular query vector. And because of this, we have to perform such operations. We have to use such algorithms. So I hope you must have got an overview how vector databases works. Now we'll see into the detailed internal working of vector DBs. So generally, we can say that the working of vector databases takes place in three processes. The very first thing is indexing. The next thing that comes after indexing is querying. And the third thing that comes after querying is nothing but post-processing. Now, talking exactly, every vector database might have different functionality associated inside it. But in general terms, these three things for sure happens inside the internal working of vector DBs. So let's have a look at all these three concepts one by one, starting with indexing. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. Very first step in the pipeline is indexing, where the databases uses the algorithms like product quantization, that is also called as PQ, locality sensitive hashing, LSH, or hierarchical navigable small world, that is HNSW. This particular process maps the vectors to data structures that facilitates faster searching. Now, by organizing the vectors in this particular way, the database can quickly narrow down the search space. So basically inside this particular indexing technique, what we basically do, we create a data structure. Now that data structure is created to smartly store the data whichever we ingest in the vector DB. Now, to create those data structures, we have different algorithms. For example, PQ, LSH, HNSW, all these algorithms are designed in such a way that it will create a data structure which will further create things easy for retrieval. So in the previous video, when I was explaining you the drawbacks of using relational databases to store vectors, There I have shown you an example where we have seen whenever a new query vector enters, and if there are millions of records present inside the database, then it's not an efficient way to one by one search for that particular query vector inside the database. It is nothing but linear search where we have to iterate over the millions of records to find out the closest match of that particular query. And not only we have to search for that particular closest match, inside that we also have to compute the similarity matrix for that particular match to get that particular closest match. So traditional way of storing the data one by one is not at all efficient and smart way. Instead, what we can do is we can introduce this concept of indexing where we can use this set of algorithms to create smart data structure. Now let me tell you what exactly indexing is. Let's say we have millions of records that has to be stored in the vector DB. Now what we'll do is we'll arrange those millions of records in a way that whenever the query vector is fired, it will be easy for us to compute the closest match in a faster way. Now, I hope you must have got an idea of what exactly indexing is. Don't worry about all these algorithms. We are going to look into all of them one by one in the upcoming videos. So stay tuned for that. So now that we have seen the first step which vector DBs use, that is indexing, let's move on to the next step where the working includes the querying. Now let's see what exactly happens in this particular step. During the querying step, the database compares the query vector to the indexed vectors in the dataset. Now, note one thing here, we have used the word index because we have already performed the indexing technique before. We have applied the algorithms to create a data structure to store the vectors efficiently. So during the querying step, the database compares the query vector, the query that is fired by the user. The vector of that particular query will be compared with the index vectors present in the dataset. That is nothing but the vector database to find out the nearest neighbors. This involves applying the similarity metric associated with the indexing algorithm. So whatever algorithm we have used, there will be a similarity matrix for that particular algorithm, and we can use that particular metric to compare to find out the closest match. Now this measures how close each particular vector in the dataset is to the query vector. Using that particular similarity metric, we can simply find out which particular vector is closest to the query vector. And this is how, in this particular querying step, we find out the closest match. Now, obviously, there is not at all one single closest match for that particular query vector. There can be multiple such closest match. And also we cannot say that the vector which is the closest of all the vectors present in the dataset will always be the relevant chunk that we require. No, it's not like that. So that is why we always retrieve the top k chunks out of the dataset. Now that we have got some closest chunks that is relevant to this particular query vector, let's move on to the next stage of working. And that particular thing is nothing but post-processing. Now, once we have got the relevant chunk, we'll perform post-processing on it. So let's see what exactly happens inside it. So here in some cases, after identifying the nearest neighbors, that nearest neighbors are nothing but the closest vectors that we have got by performing the similarity matrix. The database performs additional processing to refine the results. So here, out of the nearest neighbors, on top of that, we perform additional processing to filter out the results. This post-processing can include re-ranking kind of technique, re-ranking the nearest neighbors using a different similarity measure to ensure the most relevant vectors are returned. So here what we'll do is, let's say we have retrieved, let's say from the previous stage, we have retrieved 5 top relevant results from the database. Now in this particular stage, that particular 5 relevant results will then be further processed. Now what we'll do is we'll use a different similarity matrix to again shuffle those 5 top relevant results, and we'll shuffle them in such a way that the most relevant out of all these 5 will come at the top. So this reshuffling or reapplying the similarity measure is just to ensure that the most relevant vectors are returned. So this technique is nothing but called as re-ranking. So when we talk about re-ranking, there is not only one single algorithm that is used inside it. There can be multiple such ways through which we can perform the post-processing of the relevant chunks that we have retrieved. So all these algorithms and all the similarity matrix are very much interesting. We are going to have a look at all of them one by one, which will definitely help you make your rack pipeline very much better, very much efficient, and accurate in terms of getting the results. So stay tuned for all of this. And here we come to the end of the video. We have seen the internal working of vector databases. We also have gone through different set of algorithms that are applied inside the working of vector database. I hope every single concept is clear to you all. If you guys have any single doubt regarding this particular video, then you can post your comments or suggestions in the comment section. I'll be happy to solve it. For more such videos, do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.